What's up, y'all? So today I want to talk about AlphaEvolve from Google DeepMind. I think this is one of the better examples of what agent work looks like when there's a real feedback loop. And I know that sounds a little abstract, so we're going to dive into this. AlphaEvolve is not a normal coding assistant. It's not like open a repo and ask it to add a button. The simple version is that it uses Gemini to propose algorithm changes and then tests those changes, scores them, keeps the useful ones, and then keeps searching. So instead of just writing code that sounds plausible, it's doing the thing that I keep wanting from agents: make a change, run the check, see if it got better, and then repeat. That's the whole reason I care about this, because a lot of AI demos still live in the world of, okay, look, it generated a file. Cool. But the more useful question is, did the file work? Did the score improve? Did the test pass? Did the system get cheaper, faster, more accurate, or less annoying? AlphaEvolve is interesting because Google's saying yes in a bunch of places. They can measure that. The numbers in the DeepMind post are pretty wild. They say AlphaEvolve helped improve deep consensus, which is a DNA sequencing error correction model, with a 30% reduction in variant detection errors. They applied it to power grid optimization and raised the ability of a trained graph neural network to find feasible solutions from 14% to over 88%. They used it on Earth AI models and increased disaster risk prediction accuracy by 5% across categories like wildfires, floods, and tornadoes. They say it suggested quantum circuits with 10 times lower error than previous baselines. It helped optimize next generation TPUs, and it reduced Google spanner write amplification by 20%. And then there are commercial examples too. Klarna doubling training speed of one of its largest transformer models, FM Logistic getting a 10.4% routing improvement and saving over 15,000 kilometers of travel annually. Now, obviously, this is Google talking about Google's system, so you should read it with that context. But even if you discount the marketing layer, the pattern is useful. The agent is not just chatting, it's searching, it's trying candidates, it's using a score. And the score is not vibes. It is not, does this paragraph feel better? It is, did the circuit have less error? Did the routing improve? Did the model train faster? Did the database write less extra data? And that's a very different kind of AI work. The reason I think builders should care is that this pattern scales down. You're probably not optimizing quantum circuits today. I'm definitely not, but if you're using Claude Code or Codex or any coding agent, you can steal the shape of the workflow. Give the agent a clear goal, give it a way to test the result, give it permission to try small changes. Make it keep the winner and throw away the loser, and that's basically the useful version. For example, if I'm working on a dashboard, I don't just want the agent to make the UI prettier. That's too vague. I want it to run the page, check the console, verify that the API returns data, make sure that the empty states render, and maybe use playwright screenshots and then tell me exactly what changed. That is a score loop. If I'm working on a script, I don't just want the agent to say this sounds better. I want it to check word count, banned words, punctuation rules, source URLs, database status, dashboard visibility. All the boring stuff that decides whether the thing is actually usable. Again, score loop. And if I'm building a client automation, I don't just want the agent to draft the workflow. I want it to test the webhook, inspect the payload, confirm the email arrived, check the database row, and make sure the user-facing result is correct. Same idea. The agent gets better when the environment can answer yes or no. This is also why I think some agent demos feel magical and some feel kind of fake. When the output can be measured, the agent has something to push against. Code can run tests, routing can measure distance, a compiler can measure speed, a database can measure write amplification, a model can measure accuracy. But if the task is just write a strategy or make this more compelling or create a business plan, the feedback is mushy, and that doesn't mean that AI is useless there. I use it for fuzzy work all the time, but it does mean you need more human judgment. You need taste, you need context. You need to know what is actually true. With AlphaEvolve, the job is set up so the system can be wrong a bunch of times and still make progress, because the bad candidates get filtered out. That's a big deal, and I think that's the part worth bringing back to normal builder work. If you want better agent output, don't only improve the prompt. Improve the test around the prompt. That might be a unit test, it might be a browser check, it might be a lint rule, it might be a cost target, it might be a before and after metric, or it might be a human approval step where the agent has to show you a diff and explain the risk. The prompt matters, but the loop matters more. The spanner example is a good one because it's boring in the best way. DeepMind says AlphaEvolve refined compaction heuristics in Google Spanner and reduced write amplification by 20%. The plain English version is that when a database stores data, it sometimes has to rewrite data in the background. Write amplification is when the system writes more data than the original request because of how storage is organized. If you can reduce that by 20%, that can matter a lot at Google scale. And again, the important thing is that this is measurable. You can run the system and see whether it writes less extra data. That's the part that makes the agent useful. It's not arguing that the idea is elegant. It's proving that the behavior improved. Same with the logistics example. FM Logistic used it for routing and found a 10.4% improvement over heavily optimized solutions, saving them more than 15,000 kilometers annually. That's not a brainstorm, that is a route length. That kind of feedback gives the agent a real target. And once you start seeing it that way, you can look at your own workflows and ask, where do I have a real target? Maybe it's response time, maybe it's conversion, maybe it's cost per run, maybe it's the number of manual steps, maybe it's the error rate, maybe it's the number of support tickets caused by a process. If you can measure it, you can probably put an agent in a loop around it. Not fully autonomous necessarily. I don't think the lesson is remove the human and let the agent go crazy. The lesson is give the agent a scoreboard and make it show its work. This also connects with something I've been thinking about with AI coding tools in general. The agent that just writes a ton of code can create a mess very quickly. We've all seen that. Huge pull requests, weird abstractions, files that technically work but nobody wants to maintain. But an agent that is constrained to small attempts with a real check after each attempt is much more useful. That's why I keep coming back to small verified units. Make one change, run the test, check the page, read the diff, commit only the part that worked. That sounds slower than letting the agent run wild, but in my experience, it is faster because you don't spend the next day untangling a giant mess. AlphaEvolve is obviously operating at a much more advanced level, but the philosophy is familiar. Try a candidate, score it, keep the good one. That's it. And honestly, I think this is where the serious AI work is going. Not agents that sound confident, agents that can operate inside a loop where reality pushes back. If the output is wrong, the test fails. If the route is worse, the score drops. If the model is slower, the benchmark says so. If the UI is broken, the browser shows it. That is the kind of agent I want more of. So if you're trying to use this today, here's how I would translate it into normal work. Pick one process where you can define a clear before and after. Maybe your app build takes too long. Maybe your content pipeline has too many manual checks. Maybe your onboarding flow drops people on mobile. Maybe your internal tool has a slow query. Then don't ask the agent to just generally improve it. Ask it to find one change that improves one metric. Give it the command to run. Give it the failing test. Give it the screenshot requirement and give it the query timing. Give it the file where the result gets checked and then make it report. What did I try? What changed? What got better? And what got worse? It sounds less magical than a fully autonomous agent, but it's way more useful because you can trust it, or at least you can verify it. And that's really the line for me. I don't need an agent to be perfect. I need the workflow to catch enough of the mistakes that I can keep moving. AlphaEvolve is a huge Google scale version of that idea. For the rest of us, the takeaway is smaller but still valuable. Stop treating agents like writers that hand you a finished answer. Treat them more like search systems that need a score. Let them explore, but make the scoreboard real. That's where I think the useful stuff happens. Anyway, that's my take on AlphaEvolve, and if you want me to do a more hands-on version of this, maybe setting up a tiny loop that tries to improve a test score or page speed number, drop a comment and let me know. Thanks so much for watching. Stay tuned, and bye.